So we were discussing about a class robot, right? So class robot, which is a class robot, which takes few things, right? What are those? First one is self, comma, name, comma, color. So these things we were discussing in the yesterday class, right? So where we were talking about init. Okay, so constructor is whenever we're creating anything, if you want to perform something, right? So we'll call this constructor. Let me increase my font size 1 minute. Let me increase my font size. I hope now it is visible more. Okay. Definition first will go with the constructor, right? The constructor is called whenever we are sending or using some data. When we are creating an object directly, we can send variables to the constructor. So color, the name is for the robo name and color is for the robo color. Okay. So this is again a function, right? Init is a function. So we'll be writing that with the definition. Then self dot name is equal to name. Okay, self dot color is equal to color. Self dot is on is to check whether a robot is on or not. Okay, that uh, we are declaring it as false. We are not taking from the function. It is not compulsory that we should take from the while a robot is created. Anything you can set by default. If you want to set anything by default, then you can declare that in the okay. So then so here whenever a robot is created, what will write something like a blueprint is used. What is class? Class is a blueprint, right? Blueprint is used. Okay, a new robot named. So here we can get that name using the curly braces, right? Curly braces, then self dot name. Okay, and its current status is, what is its current status? It's off, right? So that we should get from the is on. Again, we use the curly braces, self dot, what this is on is a variable where we are using that for the get the status of the. Okay, so here we need to close the double quotes, otherwise it will throw the error, right? Okay, so is on, self dot is on, and we are closing that. So that's what we will be using in the print, right? So F colon I used, that is the reason it is not throwing that. So then we'll write another function where whenever we call it, say we want to know about that robot, then we'll create any function like describe. Okay, into this we'll send the self variable. So which because it has all the features of this particular robot, right? So what it will do here after describe, we'll keep the status to is equal to on, and on here we can write an if else. So status is on if is on is true. If status is off, if is on is false, right? So that we can write in a single statement. So status is equal to on if. Okay. So if what is a Boolean variable here? Is on is a Boolean variable, right? So what we'll get that condition dot by using is underscore on. Okay. If it is true, then it will be on, or else it will be off. So status is off, right? So what we are declaring here, status is on if self dot is on is true. Okay. Else it will be off. Here we initially we have declared it as a false. So it will be status will be declared as off. Okay. Then print f. What it will do, it will declare its name and its status, right? So if we call this describe to robot, it should display its name as well as the its status. So where do we how do we print it? Where do we get the name? Using the self dot name. Okay. Where do we get the status of the robot? Is it will be in the status, right? So my name is the curly braces self dot name. Okay, my name is self dot name and my status is okay self dot, not self dot. Now we have mentioned it in status, right? So we will give directly in the status. Okay, then closing the quotations, then closing the print parenthesis. Okay, then so this is a describe function. Then we'll write another function called toggle. So we can make power to on or off by using this function. So what we'll do, if it is on, we'll make it off. If it is off, we'll make it on. Okay, so that is the toggle power function, right? Again, we'll send the self here. Okay, colon and self dot is underscore on is equal to what we are doing, simply writing not of self. So if it is on, we are making it as off. If it is off, it will make it as on. Okay. So print. So what we have done, we have toggled, right? We have changed the power status. If it is on, we have made it off, or if it is on, we made it. So that will mention here in the print statement. The curly braces we use for name of the robot, getting the name variable. Okay. And my name, my power is toggle. Okay. My power is toggle. Okay. So this is okay. Let me check did I will ask you, anyone who, if we could any, before I execute the program, if you could tell me if I did any wrong, you can write in that if I did any wrong or anything, if I have done, please you can tell me. Okay. So I hope no wrongs are there. You can tell that in the question and answers, right? So I hope my screen is visible, right? Yeah. So now we'll create an object. This is a class, right? So for that, we'll create an object. So robo1 is equal to robot of what we have to send. We have to send the name Sandy, okay, comma, some blue, okay. So we're executing this. So what is happening when we created this? A constructor is called. So in the constructor, we wrote blueprint is used, a new robot, Sandy, and its current status is false. That is printed. Right now, we want to check with the another function, right? So we'll use the object robo1 dot describe. Okay, so here what happens? It will describe its status. Okay. So my name is Sandy and my status is off. So what we'll do, we'll toggle and again we'll ask for the describe. So robo1 dot toggle power. We'll use the toggle underscore power. Toggle underscore power. Okay, we'll call this. Then what happens? This status should be changed to on, right? Did I? Yeah, spelling wrong. Don't worry, spelling is wrong. I always do spellings wrong. What is the syntax? TAGGEL I have wrote. So Sandy's power is toggle. Now if I write robe1 dot describe, then what it should print? The status is on, right? So like that, we can use the class to, and we can use the attributes and all attributes as well as the functions also. We can create like we can create multiple robots. Okay, we can create any number of robots. Okay. So we can create for a single class by we can create the multiple objects. Okay, and so we can create any number of objects with a single class. So that is the concept of classes and objects. We will discuss more once we understand more about this. Okay, so now we'll go to the next topic. Next topic, exception handling and all. Multi-threaded programming. Normally, Java, it supports multi-threading. Mostly, Java is meant for the multi-threading. That means whenever two parallel processes are required to run, it solves the time as well as because we are running or living in the distributed world. Every work can be shared by different people or different nodes, different processors. So it can be distributed. So what happens with the distributed work? So the time is, the processing cost is same because it may be distributed, but the cost may be same, but the time and quality will be reduced. So to reduce the time as well as to increase the quality, we use this multi-threaded programming. Ashutosh Sharma, your hand is being raised many times. Just you write a question in the question and answers. The team from the team will be answering you directly or through the buddy. Okay. So multi-threading is programming. We are from E2P. We can't answer every question. Most of the questions. So most of the questions can be answered by your buddies as well as the team from the RCAP, right? So multi-threaded programming or multi-threading in Python generally is executing program parallelly in a different threads. Like that is needed, normally needed when you are driving the car, you are driving the car, and you want to listen some music, right? So what you're doing, you're parallelly driving and you're switching on the uh, dashboard of the your car and you're switching on the music system. So both are running parallel. Normally, if you could not do what you have to do, you have to stop car, then listen the music, then again after completion of the listening the music, you have to again start the car, right? So that is you not could not do the work parallelly. If you could not do the work parallelly, or if you want to make a call, if you are very good enough in the driving, and if your car is having the, I don't suggest talking in with the mobile in the cars, but if the car is having the option to integrate, then what you'll do while you're parallelly driving, you'll be talking, right? So that when a program also can be run in different threads parallelly, then we can use this multi-threaded programming or multi-threading in the Python. So multitasking is a process of executing multiple tasks simultaneously. We use multitasking to utilize the CPU. So to utilize the CPU parallelly, if it is capable, normally what happens, one after the other functions are to be executed. If you're keeping them in the thread, they can be executed parallelly, right? So multitasking can be achieved by two ways or classified into two types. One is process-based multitasking, that is we call as multi-processing. Second one is thread-based multitasking, that we call as multi-threading. So process-based multitasking, okay, is a multitasking where we are executing multiple tasks simultaneously, where each task is separated, independent process and a program. So it's a if you are talking about a program, it is called as a process-based multiple multitasking. So what we are doing, we will be executing multiple programs where each task is written in a separate program, like or executing any program. Like you can see multitasking in the process-based is typing a Python program in the notepad, parallelly listening to the audio songs, and downloading a file from the internet. All we are doing them parallelly, that we call as a process-based multitasking. Then all these above three tasks are performed simultaneously in the same system, but there is no independence between one task and another task, right? So process-based multitasking is best suitable at operating system level, not at the programming level. Okay. So thread-based multitasking is we call it as a multi-threading. While executing the multiple tasks simultaneously, it is the thread-based multitasking is. So you can see thread 1 and thread 2. You see parallelly, first 5 lines we are running in the thread 1. Second, first 5K lines we are running in the thread 1. Second 5K lines we are running in the thread 2. Okay, so what we are doing here, we are executing the multiple tasks simultaneously, where each task is separated, independent part of the process is called as a thread-based multitasking. So we are here, what we are doing, we are executing them simultaneously. Okay, we call it as a separate independent part or a process, which we call as a thread. So each independent part, we call it as a thread, and thread-based multitasking is best suitable at a programming level. So say example, we have a 10K line of code where last 5K lines of code doesn't depend on the first 5K lines of the code. So we need not to wait. Why to wait if there is no dependency on in the lines of the code? Then what we can do? We can execute the both simultaneously in a two threads. So it will take less if the CPU is capable. Then now CPUs are capable. Why? Because we are using the cloud. We can scale it to any size, right? We can increase the scale, or we can increase the capacity of the CPUs at any time. So it takes less time to complete the execution. What we are doing, because the last 5K lines are not dependent on the first 5K lines, we can run it in the separate thread. Okay. So any type of multitasking use it to reduce response time of the system, which improves the performance. Okay. So here in the multi-threading, once again, I'm repeating, a thread is a lightweight process. In simple word, a thread is a sequence of some instructions within the program that can be executed independently of the other code. So it is not dependent. It is very loosely coupled. I think all of you know what is loosely coupled, tightly coupled programs, right? Loosely coupled means one program is not dependent on the another program. Tightly coupled means one program is dependent on the other program. That means the output of the other program may change the execution of the another program. The output of the program one can change the execution of program two's, and program two's output can be changed with the program one. So when it is, we call it as tightly coupled. Loosely coupled means they are independent. They are not dependent on each other. The payment of any order should be done only after checking of the availability of the product in the inventory. Okay, and it should be locked. Say if someone is buying some mobile, it should be while before going to the payment, it should check that mobile is there in the inventory or not. It should cross check, and after cross checking only, if it is there, then it should lock it that it's already processed. Then only payment, it should continue the payment, right? So here, this payment program is dependent on the another program. It is tightly coupled with another program called inventory check, right? So, and keeping the lock on the product, right? So it is tightly coupled. It is tightly coupled, right? So someone is searching the website for another product, parallelly doing the payment. This searching in the same website for another product is not dependent on the payment, right? So this is that process, and this process are both are different independent processes. So this we call as loosely coupled. So whenever we are having the loosely coupled program blocks, we can run them in the what we call threads. Okay. So coming to the robotics or chatbots, whatever we are implementing, right? So whenever one person is chatting, okay, another person is also chatting in a different context. So both both programs will run in a different threads. Okay. So at the same time, in the thread itself, he's asking for the analysis, some analysis. And instead of making him to wait, a thread can be generated to do the analysis. He has given some, the robot has got some image. Parallelly, it is talking with the its guardian, its owner, right? So it has scanned the surface and it has sent to the server or its own model to check whether the surface is wet or any problems are there for moving. So that if it is taking some 5 to 10 minutes, meanwhile, the robot has to engage the owner. So what it will do, it will parallelly run the thread of analysis of image, and it will also parallelly run the process of talking with the owner, right? So these two threads parallelly is running. So that we call as thread concept. So a thread is a lightweight process. In simple words, a thread is a sequence of some instructions within a program that can be executed independently of the other program, other code. Okay. Threads are independent. If there is any exception in one thread, it doesn't affect the remaining threads. Okay. And generally, threads share the common memory area as shown in the figure. A thread is executed inside the process, and there can be multiple processes inside the OS, and each process can have the multiple threads. So you can see process 1 is having the T1, T2, T3, which is parallelly running, and process 2 is also having T1 and T2. These two threads parallelly it is running, right? So like that, in an OS, we can run for a process different threads. So multi-threading is a process of executing multiple threads simultaneously, and multi-threading allows you to break down the application into multiple subtasks and run these tasks simultaneously. In other words, the ability of a process to execute multiple threads parallelly is called as multi-threading. Ideally, multi-threading can be significantly improve the efficiency of the program. So multi-processing and multi-threading both are used to achieve multitasking, but we use multi-threading than multiprocessing because threads share a common memory area, and context switching between the threads takes less time than the process. So that will be very useful. Instead of going with the multiprocessing separate, running it as a separate execution, in the same, we use the multi-threading concept where it shares a common area. So we easily, an updation done by one process can be updated on the same memory. The same can be used by the other process. Okay. So mainly its advantage is speed of computation, and it remains the program responsive while one thread waits for input, the another thread runs the GUI at the same time. So say two processes are there, a GUI is there. Okay, so one is for the input waiting, one process, one thread may be waiting for the input. Parallelly, the other thread may be giving the output, right? So like that, we can run using the multi-threading. We can make the website responsive. Say if two threads are there, two programs are there. One is waiting for the input. We are making the website blank until it completes. Then only we'll make the other thread or other program to respond or give the response to the end user. Then what it is wasting of the time, right? So if they are independent, if they're not dependent, so why to make user to wait for the both the threads? Because if one is already engaged with the input, then other can answer the user, right? Other can give the response to the end user. So that is the main advantage. So it raises the possibility of the deadlocks, but disadvantage is the deadlocks may, as we said, maybe they are loosely coupled. We are not saying they're not coupled. We are saying loosely coupled. That means there may be some connection somewhere where they are dependent. That we call as loosely coupled. So we're not saying not coupled, right? That means there may be chance of occurrence of the deadlocks. I hope all of you know what is a deadlock, right? Anyone don't know deadlock, please down thumb, give the down thumb. Yeah, everyone knows deadlock, right? Thank you. Only two guys don't know deadlock. A few don't know the deadlock. So deadlock is like, it is like we are waiting for, so we are waiting, say process 1 is there, process 2 is there, process 3 is there. Okay. Process 1 is waiting for the completion of an event in the process 2. And it is in the kept in lock. and process 2 is waiting for the completion of work of the process 3. Okay, and it is in the lock. And process 3 in loop, it is waiting for the P1, process 1. Then a deadlock occurs. Okay, so they are waiting in a loop for each other. Okay, so like person 1 wants to give some data amount to person 2, right? And person 2 wants to give the amount to the person 3, and is waiting so that if person 1 gives the amount to person 2, then he will submit the same to the person 3. And person 3 is again waiting. Person 3 wants to give the person 1, but he's waiting for the person 2. So P1 is thinking P3 will give me amount, then I can give to P2. P2 is thinking P1 will give me amount, I can give to P3. And P3 is thinking P2 will give me amount, I can give to P1, person 1. Like that, 3 are waiting for the money, but they are in the deadlock. Okay. So it happens in our friends, right? So global interlock, we call it global interpreter lock. We call it as GIL. So you please remember this word GIL. So execution of Python code is controlled by the PVM, right? You know, Python virtual machine. So Python was designed in such a way that only one thread may be executed in Python PVM. Like similar to how multiple processes in a system share a single CPU, right? But many programs may be in memory, but only one is live on the CPU at a given moment. So likewise, although multiple threads may be running within the Python interpreter, only one thread is being executed by the interpreter at any given time. So maybe threads are parallelly, many threads are running, but only one thread is executed by the interpreter. So like as I said, if it is an input waiting for the input, parallelly it will give the GUI, but it is not which is waiting for the input, it is not waiting, it is not using the interpreter, right? Like that. So access to the Python virtual machine is controlled by the GIL, global interpreter lock. So the lock is what ensures that exactly one thread is running at a particular time. Okay. So this is essentially means is a process can run only one thread at a time. When thread starts running, it acquires the GL. Okay. So what is GL? Again, global interpreter lock. So this it's when a thread starts, first it will take the GL. Then after that, when it waits for IO, it will release the GL. So whenever someone it is waiting for the user to enter some data, or it is waiting for the data to come from somewhere else, what it will do, it is not executing something, it is not using the CPU. Then what it will do, it will simply release the GIL. Okay, then the other thread wait for the GIL. If the GIL is removed, released, then it will use the GIL. And when it go for waiting for IO, then it will what we call, it will release the GIL. So threads, first it will log the GIL, it will go use the GIL. Okay, interpreter lock, right? Global interpreter lock. It will use the GL. Once its execution is over, when it is waiting for the IO, it will release. Then other thread will make use of the GL, and it will use or interpret. Then it will release the GL. Okay. So Python offers two modules to implement the threads in programs. One is thread module, okay, and threading module. Thread module is provides a low level primitives for working with the multiple threads. Okay, so it works on a basic things. So like underscore thread module supports one method to create a thread, that is thread dot start new thread. Okay, and it will call whatever functions we call or arguments we can pass them. So this method starts a new thread and returns its identifier. So whenever we use the start new thread using this thread, it will create a new thread and returns in its identifier. It will invoke the function specified as a function parameter and with the passed list of the arguments. So here we'll send the function name which we want to run in this thread. Okay. So when the function returns, the thread would silently exit. Okay. Here args are a tuple of arguments. So we can use an empty tuple to call or without an arguments. Okay. So here Python 2x is used to have the thread model, but it got deprecated in the 3.x. Okay. It is renamed to underscore thread module for a backward compatibility. Okay. So here you can see from underscore thread import start new thread. Okay. So we are importing this thread from this library. Okay. So from time we will import the sleep. Then here we are creating a display n for I in range to 5. So here what it print then, that means what it will print, it will print I value, okay, the number of times, okay. Then not I value, actually it printing the n, right? So whatever we send to this display, that will be printed 5 times, okay. So then we are starting a new thread, okay, using this. So where what is the function syntax for starting a new thread? Start underscore new underscore thread. Okay. Then display is a function which we are calling, and we are seeing hi. So one thread will be running parallelly. Then again we parallelly calling another thread. Okay. So then we are calling another, or we're sending to this display hello, right? So then we are also calling sleep 2. Okay. So what happens? First it will start, then it is going another thread, it will print hello, then it is because it is going to sleep. Meanwhile, the hello is going to sleep. Then this the first thread will be completing its task, and then it will be closed, right? Once the function is function's work is completed, it will be automatically closed. Then hello hello will be displayed. Okay. So that's how we'll execute that also in the Monday's class. So then we are going to the creating thread using the threading module. So to implement a new thread using a threading model, we use the code snippet called threading.thread. And target is equal to none, name is equal to none, and arguments. Target is the callable function to be invoked by the run method. Okay. Defaults to none, meaning nothing is called. Okay. And name is a thread name. So we can give any name to the thread. By default, unique name is constructed by the form thread end. So it's not like the previous one. So it is works in different. So args is the argument tuple for the function invocation, which by default it is null. Okay. So you can see we are importing the threading. Okay. Again, same display function. We are printing the same. Here we are using the T1 is equal to threading dot thread. Target is equal to this function display, and arguments is equal to thread1. And T2 is equal to threading dot thread. Target is equal to again display, and it is thread. So T1 dot start, T2 dot start. We are starting the first thread. Okay. Here we are starting the first thread. We are starting the T2 start, and wait until thread1 is completely executed. Then we are calling the what we are saying here, we are in the T1 dot join, where it will wait until the thread1 is completely executed. And here when we say T2 join, and when everything is done, it will wait until the thread 2 is completely executed. Then the both threads will be completely executed, right? So we will run this by on the Monday. So it will little bit confusion where exactly it is required in the robotics or a chart boards, or while we are implementing the different A and ML algorithms where these threads concepts are used. That is very much required because where will be running in the high end systems where we need huge calculations, we need huge time, we need huge CPUs. So how do we use the thread concept to share our processing? What size of the file, what type of programs can we parallelly run using the threads? So that we will discuss in the next class. Okay. So thank you very much for listening carefully. Uh, so today threads we have discussed, and we have also seen the example of classes and objects. And by Monday we'll go with the execution of this, and we'll also start the NumPy and pandas. Okay, all of you, why I'm giving once a concept is discussed, why I'm giving the time to you is to you also parallelly learn those things. When see today we discussed about class